Hi, Sunil. I'm TJ, and I'm one of the members for this project where we're doing a variable fan.
Hi, Sunil. I'm David. How you doing? This this is our variable fan. As you can see, we 3D printed a fan blades next to the stepper motor, and pretty much what it can do with this potentiometer, we can control the speed of the fan and also the direction of fan depending on where you turn the knob at. So what we're going to do right now is demonstrate that and show you how it works. So first we're going to turn on the fan, and TJ will turn the knob to show you how that works. So he's turning it to the left, and it's slowing down. And now it's changing direction, and now it's going to build back up the speed. And then that's max speed. So it's on both ends, it starts at max speed, and then as you go towards the middle, it slows down. And so that's pretty much, that's our experiment. We use the Freedom board right there, and then TJ will explain what's going on underneath.
So, like you said, we use the Freedom board, and we have a stepper motor controller that we are using. It's a Polalu stepper motor controller. We're sending two signals from the board, the Freedom board. We're sending a direction signal, which is either high or low, and then a step signal, which is just a square wave step. Depending on how fast we want, we can change this what the square wave is. So we're sending a step signal, and the controller is sending all of the signals to the motor, which causes it to go either left or right, depending on what we send it, step or direction. And we also have the potentiometer. So we have the potentiometer bias between 0 and 3.3 volts. And in the center on the wiper part, we have it going straight to the analog input. And the analog input is, once it gets the analog input, it can tell in the program how to change the fan. And we have it powered by a 12 volt or 11.1 volt battery, which is regulated down using a regulator to 5 volts. And then the 5 volts is regulated down to 3.3 once it gets on the Freedom board. So the 12 volts is used, or the 11.1 volts is used for the motor, and then all the regulated power is used for the rest of the circuitry. And that's pretty much our project.
Yep, and that's our project. Cool weather and a hot day. Thank you.
The potentiometer is feeding the analog input into the Freedom board, which is controlled by the user. And depending upon the analog voltage, the different stepper controls are sent to the stepper motor controller. The battery is 11.1 volts, which is feeding the power regulator and is giving 5 volts to the Freedom board, which is then converted to 3.3. 5 volts and 11.1 volts are also given to the stepper motor controller, which feeds the stepper motor. After the start of the program, the analog voltage is read from the analog input pin. If it is below 0.65 volts, it is forward, and if it is above 0.65 volts, it is considered reverse. The analog voltage is then compared to determine the value of the step delay. The coinciding steps are determined by the voltage if it's in a certain range, 0.015 volts, all the way up to 1.1 volts is the determination. Depending upon what it is read, the delay is given to the function below, and the direction is set, and the speed of the actual pulse is set as well. The direction determines the direction that the motor is spinning, and the step determines the speed of the actual motor itself.